CIS 250 data.
Okay, this next part we're going to talk about is basically sorting different sets of nodes. And this is called a merge sort. So we need to take a string of objects, could be arrays, nodes, could be just regular objects, whatever they are. We need to basically take them and sort them and then merge them back together. The book talks about what's called a term called divide and conquer, where we divide it into separate little items that we can kind of sort in these little things and then kind of merge them back together, and it makes it a little easier to do that. They call it divide, recur, and then conquer. So basically here's how it works. So we have this string of objects, and we're just going to use numbers in this case, and we need to get them sorted. So what we do is this, is we take them and we split them into two separate groups. So I take 85, 24, 63, and 45 and throw them down here into this group, and 17, 31, 96, and 50 into this group. Then I take and split 85 and 24 into its two groups, and then 63 and 45 into its two groups, and then I split them each. So basically when I get down, I'm going to have each number in its own little grouping. So now here's what I need to do, is I take 85 and I look at 24 and I say, which one is lower? Well, 24 obviously is, so I put it first and I put 85 over there. Same thing here, which one's lower, 63 or 45? Well, 45 goes here, 63 goes there. Same thing over here, 17, 31, and 50 and 96. Now I need to take these two groups and put them up here. So what I do is I look at 24 and I look at 45 and I see which one's lower. Well, 24 is, so I throw 24 up there. Then I look at 85 and 45. Well, obviously 45 is lower. So then it looks at 45 and 63 and it sees 45 is the lowest out of those two, and it throws it up there. What's left is 85 and 63, and 85, 63 compares, it says 63, it goes up, then 85. Same thing over here. By the time we merge these, so now we've broken them down into smaller chunks, so we divided them all. And now we're basically doing a recur, where we're basically then taking each smaller chunks and then sorting them, and then sorting them, and then sorting until we got our nice big tall numbers. So then I've got 24, 45, 63, 85, same thing here. So now I've got to take these four strings, do the same thing. I look at 24 and 17, which one's lower? 17 is. I look at 24 and 31, which one's lower? 24 is. I look at 45 and 31, which one's lower? 31 is. I look at 45 and 50, which one's lower? 45 is. I look at 63 and 50, which one's lower? 50 is. I look at 63 and 96, which one's, well, 63 and 85 in this case, and which one's lower? 63 is. 85 and 96, which one's lower? 85. 96 then basically goes up. Okay, so that's basically the divide and conquer, sort and merge capabilities of Java. And again, if we look over here on this page, it kind of breaks it down, and then you're going to need to do something like this for the final exam as well. And so as far as Java coding goes, this is how we would do that. Again, I'm not expecting you to understand that. It's a little complex, a little kind of over our heads as far as this class. And then here's the merging of two sorted sets. So again, so the first thing we have to do is take our sets and break them down, and then slowly put them back in sets that are sorted. Once we have sets that are sorted, we can do a comparison between this and this and keep going back and forth. Yeah, it talks about quick sorts. A quick sort basically says what I'm going to do is I'm just going to grab a number, and that's going to be my pivot number. So if a number is less than that number, it goes on this side. If it's greater than that number, it goes on that side. And then it does the sort and merge pretty much the same way. Again, I'm not going to go into all that. So the last thing I want to cover is this thing called graph algorithms. So basically a graph it's more of a visual based type of way of organizing data. And so we talk about some of the different terminologies. First of all, we have edges, and just like we saw with a tree, we can go along the outside of that tree, and that's called the edge. So if I go from the root to a child to a child of that parent, then when we stay on the outside, that's called the edge. Edges are either directed or undirected. It's directed if they are ordered, and meaning I have to go. So directed means I have to go from this one to this one to this one. Undirected means let's get more into this, because I think it makes a little more sense once we kind of get over here.
Structures are ways to store and organize data, and for different kinds of data we use different kinds of data structures. In this lesson we are going to introduce you to another non-linear data structure that has got its application in a wide number of scenarios in computer science. It is used to model and represent a variety of systems, and this data structure is graph. When we study data structures, we often first study them as mathematical or logical models. Here also, we will first study graph as a mathematical or logical model, and we will go into implementation details later. Okay, so let's get started. A graph, just like a tree, is a collection of objects or entities that we call nodes or vertices connected to each other through a set of edges. But in a tree, connections are bound to be in a certain way. In a tree, there are rules dictating the connection among the nodes. In a tree with n nodes, we must have exactly n minus 1 edges. One edge for each parent-child relationship. As we know, an edge in a tree is for a parent-child relationship, and all nodes in a tree except the root would have a parent would have exactly one parent, and that's why if there are n nodes, there must be exactly n minus 1 edges. In a tree, all nodes must be reachable from the root, and there must be exactly one possible path from root to a node. Now in a graph, there are no rules dictating the connection among the nodes. A graph contains a set of nodes and a set of edges, and edges can be connecting nodes in any possible way. Tree is only a special kind of graph. Now graph as a concept has been studied extensively in mathematics. If you have taken a course on discrete mathematics, then you must be knowing about graphs. In computer science, we basically study and implement the same concept of graph from mathematics. The study of graphs is often referred to as graph theory. In pure mathematical terms, we can define graph something like this. A graph G is an ordered pair of a set B of vertices and a set E of edges. Now I'm using some mathematical jargon here. An ordered pair is just a pair of mathematical objects in which the order of objects in the pair matters. This is how we write and represent an ordered pair. Objects separated by comma put within parentheses. Now because the order here matters, we can say that V is the first object in the pair and E is the second object. of a set of vertices and a set of edges, and G equal VE is a formal mathematical notation that we use to define the graph. Now I have to write this graph has 8 vertices and 10 edges. What I want to do is I want to give some names to these vertices, because each node in a graph must have some identification. It can be a name or it can be an index. I'm naming these vertices as V1, V2, V3, V4, V5 and so on. And this naming is not indicative of any order. There is no first give any name to any node. So my set of vertices here is this. We have 8 elements in the set: V1, V2, V3, V4, V5, V6, V7 and V8. So this is my set of vertices for this graph. Now what's my set of edges? To answer this, we first need to know how to represent an edge. An edge is uniquely identified by its 2 endpoints. So we can just write the names of the 2 endpoints of an edge as a pair, and it can be a representation for the edge. But edges can be of 2 types. We can have a directed edge in which connection is one way, or we can have an undirected edge in which connection is two-way. In this example graph that I'm showing here, edges are undirected. But if you remember the tree that I had shown earlier, then we had directed edges in that tree. With this directed edge that I'm showing you here, we are saying that there is a link or path from vertex U to V, but we cannot assume a path from V to U. This connection is one way. For a directed edge, one of the endpoints would be the origin and the other endpoint would be the destination. And we draw the edge with an arrowhead pointing towards the destination. For our edge here, origin is U and destination is V. A directed edge can be
Okay, so if we take a look at this, we've got directed and undirected graphs. So so if we take a look at, let's say this graph right here, we're going to call this one undirected because I can go from D to G, or I can go from D to C, or I can go from C to D. Okay, so I can go in any direction at all. So there are no directions. But if we look over here, when we got an arrow, M, I can only go from M to N. I cannot go from N to M. So it's only a one-way pattern. So okay, so here we on page 626 talk about directed graphs. So we're basically trying to see, does it tell us which way to go? So the example they use is all the different airports that we have and how air traffic basically flows. So we can only go from Boston to Miami, but we can't go from Miami to Boston in this particular graph. And so we basically have the arrows. So those are directed. We can only go one way. We can't go the other way. Okay, so in this particular case, we do not have any flights that go from Miami to Boston. We only have Boston to Miami. If I needed to go from Miami to Boston, it looks as though I would have to go to I don't see any way to get there from there. Yeah, because I was going to say maybe I could go from Miami to Dallas, Fort Worth, and then there to Los Angeles, back to Chicago, but then there's really no way. So I need to find some way to get to JFK. Yeah, it looks like JFK and Boston. We can go to Boston from JFK and from Boston to JFK, but we can't go any other way. So that's directed. So directed graphs basically only allow us to go one certain way. Undirected graphs, we can go any way. You will not see any arrows basically on them. Okay, so we know what directed and undirected graphs are. So basically, so we look in this case, this is a directed graph because our edges have lines on them. So again, the lines are called edges, and the circles either nodes or vertices, and these are directed. Now, if I were to do this, let's say that I would go ahead and put a number on each line. Okay, so let's say each one of these lines we're going to have a number value. So now we know how many miles it is from this vertex to that vertex. Okay, when we see numbers like that, that is now what is called a weighted graph. It's weighted, meaning we know the numeric values between the vertices. And this is a perfect example because these types of graphs between airports, we know the mileage between one to the other. So if we have, let's say, some type of data, I would have to know some type of numeric value to get from one node or vertex to the next. So when we see numbers on those edges, it's called a weighted graph. If we do not see any numbers, we basically call it an unweighted graph. So I could have a directed weighted graph or a directed unweighted graph. I could have a weighted directed graph or a directed unweighted graph. So again, directed means the edges have arrowheads. Weighted means they have numeric values between the different lines. Okay, so weighted, unweighted, directed, undirected. Okay, so there's a couple good videos. I was showing one of the videos. I was trying to get a good introduction. It went kind of long. So anyways, that video, another video on graphs are in this week's videos. There's also, I think the previous week has some good videos on stacks. So it gets more into stacks. So again, watch those. Read up on those, and again, the final is out there. Tonight's homework is going to deal with the coffee database. Try to get that to work if you can. Hopefully you can. If you can't, then we'll have to figure something out. So anyways, give me a call, email me, whatever. We'll try to figure something out. Try to get that database to work for you. Again, I will put the instructions on how to get that set up correctly and make it work. Again, if you have any questions, give me an email, give me a call. Again, a week and a half, so a week from this coming Monday, make sure you have everything turned in, all of your homework assignments. Go out to eLearning, check to see if you have a grade for that particular item. And if you do not have a grade, check to see if you've got something turned in. If you don't have anything turned in, get that turned in, okay, to basically receive points for that particular homework assignment. I don't care, go back, do old ones. I'm not going to deduct any points. Get those into me so that we can get you the points that you need to get a good grade. Again, call me if there's any questions. More than happy to help. See you guys down the road, hopefully. If not, see you down wherever. Okay, goodbye.